something like a 5 plus a 3i, and then a 6 minus a 7i. Okay, obviously this is going to be a FOIL. All right, so why don't you go ahead and FOIL it out and see if you can get the right answer. Okay, you guys probably had it before I did. Okay, so I went ahead and showed all the steps in my FOIL. I did inside terms, I did outside terms, I did inside terms, and then the last term was that 21i squared. All right, and I would assume that at this point you guys could do this a little bit in your head. There's a -1, so that's going to make that a positive. Combine those like terms there, and then when I put these two together, I put them in front because I want it in that a plus bi form. Okay, so like I said, this could be a binomial, it could be a binomial times a trinomial, any type of adding, subtracting these things they expect you to be able to do. All right, now they are going to practice. Let's go ahead and put one more on this piece of paper. They are going to have you practice the rationalizing the denominator. We did this when we were reviewing in the chapter P chapter when it was square roots. All right, so now they're going to do it with imaginary numbers. All right, the easy type of problem that you will see is just a plain number on the top, and then maybe say a 2 minus 3i on the bottom. Okay, they're going to want you to rationalize this. In other words, they want you to get rid of this. You're going to multiply by the conjugate. All right, so let's write that word down. All right, you're multiplying by the conjugate, which means what? You take whatever sign is down there in the bottom, and you multiply by a form of 1 using this denominator, but with the opposite sign. So that means I'm going to multiply by a 2 plus 3i over a 2 plus 3i. When I do that, this is a form of 1, so I'm not changing the original problem at all. I purposely choose the opposite signs because this now is a binomial times a binomial. Both the first and last terms match, and they have opposite signs. So when I choose the opposite sign, I'm doing this because that creates the factored form of the difference of two squares. So we're not just telling you, oh, memorize it, you know, like pick the opposite sign. Why do you pick the opposite sign? You pick the opposite sign because if I FOIL this out, then I get something that looks like the difference of two squares. So when I take the difference of two squares, when we did the factoring chapter, we factored it. It factored into that. That means I can multiply this really, really quick. I square the first one, I put a minus sign down, and I square the second one. So I don't actually have to FOIL because that middle term falls out every time. All right, now on top, this is a single number times a binomial. So I would be distributing that to both terms up there. So I'm going to get a 16 and then a 24i. Okay, now on that bottom, let's do it the fast way. All right, no, let's not. Let's show it. Okay, so if I square the first one, minus, now square the second term, I'm going to put it in a set of parentheses, 3i, and then square it. 3 squared is 9. What's I squared? -1, right? So then what's it do to this? Turns it into a positive. Okay, so on top, 16 plus 24i, this is going to be a 4. So 4 plus just a plain old 9. 9 and 4 is like 13. So 16 plus 24i all over 13. Now, honestly, did I do that right? Now, honestly, I see nothing wrong with leaving it just like that. All right, technically, you're not in a plus bi form at that point, okay? I can't factor anything out because that's a 13. If I could factor something out on the top and then cross out, I would, but I can't on this one. If you really, truly want it in a plus bi form, all right, you got to split this up so that you've got some real number part plus the imaginary part. So I could rewrite it as 16 over 13 plus 24 over 13, and then I usually pull that I out like that.